Good morning to all. In this video we are going to discuss about the 16-bit multiplication program for 8085 microprocessor. Before we understand the program, we should understand the input and output format actually. So input is a 16-bit number and input has two 16-bit numbers actually. One is multiplier and another one is the multiplicand. So since we are using LHLD, we should store the input data in this format. Actually it is like this. This is the memory location 4200. We should have the LSB of the first number, that is a multiplicand. In 4201 we should have MSB of the multiplicand, and 4202 LSB, and 4203 we have MSB of the multiplier. Okay, and the results are 32-bit. The results are 32-bit. So two parts are there in the result. One is accumulated carry, which is stored in 4204 and 4205. Similarly, accumulated sum will be in 4206 and 4207 as MSB and LSB in this format only. So let us take a simple example, multiplication of 1503 into 1502. We are multiplying two 16-bit number here. The result is like this. So which means this portion, that is 1B9, is called as accumulated carry, and this 6906 is called as accumulated sum. So this is a 16-bit number, this is a 16-bit number actually. We will be getting maximum of 32-bit number when we multiply two 16-bit numbers in hexadecimal. This one we should understand, and then we will go to the program. Let us see how this program is working. As usual, we are loading the first number into the HL register pair. That is 16-bit number is loaded with the HL register pair. Then it is exchanged with the DE register pair. Now we are initializing the BC register pair as 00. Now we are checking whether the number what we have loaded is having a 0000. So if it is 0000, then the result is going to be 00. Therefore, what we are going to do is to check whether both D and E are equal to 0. What we have to do is, let us say D is having some number and E is having some number. So whenever both numbers are equal to 0, when you perform a logical OR operation, the numbers, the accumulator become 0, which means zero flag will be set. Whenever the content of accumulator is equal to 0, after performing any logical and arithmetic operation, the 0 flag will be set as 1. So if at all any one register is having any one bit as non-zero, that means 1, then the accumulator will not be equal to 0. Carry, that is 0 flag, will not be set. This is what you should understand. So that is what we are doing here. We are copying the content of E register to accumulator, and the logical OR operation is performed with D. And if it is 0, then jump no 0 only, it is going to loop 2. If it is 0, it will come to the next instruction, that is loading HL equal to 00, and then jump to loop 2. So in loop 2, what do we have is, we are storing HL, which is already 0, into the result 4206. Similarly, we are loading the same thing, actually the same thing can be loaded with the SHL, store the HL to 4204. Actually this is loading the accumulated carry from the intermediate value to 4204. Actually at present 4300 is also having a 0 data. So therefore that 0 is copied here. So we will discuss this in detail when we are checking the program with the real numbers actually. Okay, let us assume this is a non-zero number. So therefore it is not 0, it is going to loop 1. Loop 1 means now we are loading the second number, that is a multiplier. And that multiplier is copied to BC register pair in these two instructions. Now we are initializing HL register pair is equal to 0, 0, 0. So now what we are going to do is, we are going to do the 16-bit addition with the BC register pair. So BC register pair is added with HL, which means this instruction means that HL is equal to HL plus BC. So content of HL will be equal to content of HL and BC. The result will be stored in HL itself. So when we are adding, whenever we are getting a carry, we have to do some operation. When there is no carry, we will go to loop 3. So loop 3, what it says, it is decrementing the multiplicand. So it is decrementing the multiplicand and then checking whether it becomes 0 as we have done earlier. If it is not 0, we have to repeat this. Okay, so it will be keep on repeatedly adding the number. So repeated addition becomes the multiplication. So let us see, interesting thing, whenever the carry is generated, it will come here. So since we have got only 3 register pairs in 8085 microprocessor, we have already used, because DE register pair is used for decrementing, that is second number is there, that is keep on decremented, and BC we are simply adding that first number, that is holding the first data that has to be repeatedly added, and HL we are storing the result of the accumulated sum. So now we have to use a 16-bit register to store the accumulated carry. That carry has to be keep on added whenever it is generated. See that now since we are going to reuse the HL register pair, we are using the push operation. Push means now the stack pointer is not initialized. So the stack pointer take the default value of 0000. When we are pushing, the HL register pair will be copied to the memory location called as FF, FE and FF, FF actually. The first one is FF and the second one is FF. So here maybe L value is copied here, here H value is copied. H value copied here and L value is copied when we are putting this push operation. When we are executing the push operation, this is considered as a default stack pointer memory location, that is 0000 minus 1 is FF. That becomes the value of L and the value of H is temporarily stored in the stack pointer. So that is very important. Now initially we are loading 4300 as 0. There is no data there. So that data is loaded here. Now it is incremented. Whenever carry is generated, it is incremented by 1. Now again we are storing the same incremented value to the same location, and we are retrieving the value of HL register pair, which is the result of this addition. Okay, so you have to be very clear what we are doing here. So we are adding the 16-bit number here. That result is available in HL. Whenever carry is generated, then you push the intermediate result to the stack pointer and reuse the HL register pair. Now HL is free to use because that HL value is stored in the stack pointer. Now what we are doing is we are initializing the carry. We have already initialized the carry into 0 in this memory location 4300. So that is incremented by 1. Again that 1 is stored to 4300. When we are popping up, the previous value, that is whatever the value added here, that is coming back here, coming back to HL register pair. Now we are decrementing, we are checking whether it is 0, we are repeating, once again we are adding. So we keep on add every time a carry is generated, we keep on increment that. Carry is loaded from the memory location and it is incremented, again it is stored back. So it is keep on running. It's keep on running. Finally, the result will be in HL register pair, that is accumulated sum will be in HL register pair, that is stored to 4206. You can see accumulated sum I have mentioned as 4206 and 7. And LHLD 4300, the accumulated carry is there that we are loading to HL and then that is stored to 4204 accumulated carry. Okay, we will verify this program with the help of our simulator. So I have already copied the program, the same program, and I have taken the data as you can take any other data now. Earlier we had this data, we will see 35, that is 1534, and it is nothing but FF and 15. See, 1534, 15 FF. This is the data. We just assemble here. You can see the data 15 FF and 1534. And we run this program. Since it is having so many number of repeated addition, it takes some time to execute. If you are trying this with the microprocessor kit, you can see it will take few seconds to execute the program. Okay, fine. Now we are getting an answer, that is 010262 CC is the answer. So let us verify whether this answer is correct or not. Okay, I think what is the answer? The answer is the results are stored in 4204 and 4206. So 6 and 7. Actually, the result is 62 CE and 0102. That's the result. Okay, carry is there now. This is 4300 accumulated carry. So we go to the calculator and find out whether the same result comes or not. So the number we have taken, the data we have taken is 1534 and 15 FF. 15 FF multiplied by 1534. So what we are getting is CC, 62CC. You can see 62CC is there. 62CC is the accumulated sum. 01D2. 01D2 is the accumulated carry. Yes, this program is working very well. You can check the program with your simulator, or manually also you can calculate with the calculation, and it will work. Thanks for watching this video. If you have any questions, ask me in the comment box. Keep connected with me for more such videos. Learn more and more about 8085 microprocessor. If you feel that why should we learn all this 8085 microprocessor in the recent years, that is 2024, I have got another video for you. You can check it out, the advantage of learning 8085 in the year 2024. Thank you.